Now we will see section 5.2, the ellipse. Now we will start with the geometric definition of an ellipse. Especially, we will concentrate on the ellipse with center at the origin. Now, what is an ellipse? Okay, let's see the definition of an ellipse. Now, in the following video, we'll see how to draw an ellipse practically. Okay, there will be 2 points always. Now you attach a string to these 2 points, and then by a pencil you're trying to, okay, you make the string tense, you give tension, and then you draw it. Okay, let's see it again. So how to make a ellipse? You have 2 points fixed near one string. By using the string, you're drawing this ellipse. So as you see, the length of the string is fixed here. So mathematically, this is how we define it. Mathematically, we say let F1 and F2 be the 2 points on in a plane. These are our pins here. Like here, I can say this is F1, and this we say F2. And the ellipse with foci, we call them the focuses or foci. Foci is the plural. Okay, foci is the plural of focus. So we have 2 focuses, so 2 foci. And is the set of all points. So we are trying to find the points. So all the points, these are the points. The blue ones are the points that have this property. Their sum here, let's say this is A, B, and we want to find another one like this one. Let's say this is C and this is D. Their sums are all same. So, like this sum is the length of the string. So this will be the length of the string in the video. So these points, all of them having this property, will make an ellipse. So the distance from the foci to a point from F1 plus the distance between the point and the second focus, they all have the same thing. Like when you change the points, you have this sum always fixed. Yeah. Okay, let's talk about some definitions of some of the concepts in an ellipse. So when we define an ellipse, we have some special terms. Okay, let's start with, always there will be 2 points, and we call them the focuses here. We always start with the focuses. They are important, so we call them foci. So foci, as I said before, the plural form of focus. So your foci might be given like these 2 points horizontally, or that they might be given like this one here vertically. So these are all foci. I mean, they're all foci, we can say. Okay. What do I say here? It's foci. Now, the ellipse will be formed by, when you draw it, you will have such thing here. When you draw this one by using the focus here, foci, you will have such ellipse. Now these are called foci. Now there will be a line having this foci on it. So we call this one the major axis. This one here, the major axis. Now we have the same thing here for this one. This becomes the major axis. And okay, no, I want to say this is foci, and these points are foci here, these 2 points. Now this is the major axis. When we say major axis, we mean always the long one. Okay, the long axis or long side. Okay, now here there will be the center of it. So let's say this is the center of it, center, and there is the center here, just at the middle of both, center. Now this one here, this red short red vertical line, and here it's this one here, short one. We call this one minor axis. So this is, we call it minor axis. So minor axis, you can take it as minor axis, short axis, short one. Always short one is minor axis. Now there are other things also. One is, of course, the vertices. So these points here, the end points here. Okay, I will use another one. I mean another color. So let's make this one red. Okay, here. These two are called the vertices. Okay. Now this is also called here the vertices. These are called the vertices. So vertices are the endpoints of the endpoints of the major axis. So these are the main concepts here. The foci, okay, I will say here I will make the list. First, foci, 2, the vertices, and here I can say this F1 and F2, and V1 and V2 here, the vertices, and here is F1, F2, V1, V2. So the vertices, this is the foci is F1 and F2, and the vertices like V1, V2, and the third one is major, the major axis, and the fourth one is the minor axis. So, and the vertices will be always the endpoints of the major axis. So this is an important one. Okay, now I will erase this one, and okay, you can pause the video and check the definitions here if you didn't understand. But I want to show you the slide here. Slide. So there's a better picture in the slide. So I want you to see it. Okay, let's see. Here is the major axis and minor axis, and there's the center, and there's the foci, and there's the vertices. So it gives everything for just a horizontal asymptote, horizontal ellipse. You can You can do the same thing for a vertical ellipse. So here it is. I mean, you can check them. Okay, now we will put our ellipse on the Cartesian plane. So we might have two cases here, and we want, okay, we are focusing on the ellipses with center at the origin. So this will be the center of the origin will be the center of the ellipse. Now we might have, okay, I will say F1, F2 here. You might have the foci at x-axis on the x-axis. So we will have such thing then. And this will be the vertex then. The vertices are like V1, V2, let's say. And okay, and we might have the other type. The other type is we might have F1 and F2 here on the y-axis, and the vertices might be like that. So okay, this is it will look like an ellipse here. Okay, let's make it better now. So we might have two cases here. I mean, this way, or okay, type 1 and type 2, we can say. Anyway, so the vertices here will be here V1, and this is V2, the vertices. And this is, as you see, the major axis on the x-axis here. Now, let's say this one here is C, let's say. Then this will be minus C. And, you know, F1 is now, what is this? It is C0, and F2 is minus C 0. And okay, let's say the vertex here, and let's say this vertex is A here, and let's say this one is the y-intercept here is B and minus B. So then this will be the vertex 2 will be minus A. So I will say V1 is A0 and V2 is 0. No, sorry, it's A minus A0. Now, as you see here, the major axis length is, okay, maybe I should write here. The length of major axis is, this will be, this is the major axis, so it will be 2A. And the minor axis is 2B. Okay, we can say this is 2B here. Okay, then now here, of course, if this is the case, like A is bigger than B. Since A is bigger than B, we have this type of shape. But when you come to this point here, if you put here C and here C, and this is, let's say, B, and here, okay, this is minus B, and this is B here, and this is A, and this is minus A. Then, of course, B is bigger than A here. And if you look at the foci and the others here, so F1 has to be 0C, F2 will be 0 minus C, and V1 is, okay, A0. Oh, sorry, this is not true. Then this V1, V2 will be 0, B, V2 is 0 minus B. And the length of the major axis is equal to, okay, it will be from B to B. So this, okay, the blue one here will be the major axis, as you see. So the length here, it will be 2 times B. And the length of the minor axis is 2a. Because you look at here, it's 2a, it's 2a. Now, when it comes to, yeah, we wrote them. Now, let's come to the very important property here. This is the very, very important part. Now, it's coming from the property of the ellipse here. It's because of the setup here. So, you look at here. If you draw a line from this focus to B and the y-intercept, and this one here, this distance will be equal to A. Now, this is because of the string issue, the distance from the focus, the sum of the sum of the distances of a point to the focus foci is fixed, so it has to be A here. And we can do the same thing for the foci here. So F1 we know this has to be B. So in here, if we write this one, it gives the Pythagorean here, c squared plus b squared is equal to a squared. So now in this case you can write c squared has this relation between b and a, b squared minus a squared. So you can say here the relation between a, b, c is c squared is equal to b squared minus a squared. Okay. Now the same thing is true for the other. Okay, I will do the same thing here. And now if you apply the Pythagorean here for this triangle, so you will say c squared plus a squared is equal to b squared. And now c squared is equal to b squared minus a squared. Now, okay, here, be careful, b is bigger than a. So, but here a is bigger than b. Sorry, this in the previous one I made a mistake. I guess this has to be a squared minus b squared. Sorry, it has to be a squared minus b squared. And now this makes the okay. This is true then. Okay, so the relation between I want to write it here. Now we have this c squared is equal to b squared minus a squared. Okay. Now this is c squared is there. So in any case, it will be c squared will be a squared minus b squared, and or b squared minus a squared, depending on this. If a is bigger than, or if b is bigger than a. So depending on which one is bigger, so c is taking the value bigger squared minus a, bigger one squared minus the small one squared. And when it comes to the equation of it, so equation of the ellipse is always like this, x over a squared. So you can say this a here is x-intercept, positive x-intercept, or you can take as negative, no problem, because you're taking the square of it. And then you say, okay, x squared, this is y squared over b squared. So it will be one of the y-intercepts. So it will be equal to 1. So this gives the equation of it. Now, these are the things we have to know about the ellipse. Sometimes we give you the equation, we ask them, or sometimes we give these information and we ask the equation, or we can directly, we give the graph and ask you the equation, or vice versa. I mean, you have to know all these. Now I want to give you, okay, I think this is, okay, I want you to see the table given and the slide. And the table, the setup is a little different, so you have to be careful because I used same A and B in both types. but there it's A and B is used for different intercepts. So be careful. If you're using the table, be careful about the setting of this table. So look at here. This is the idea here, but be careful in here. This is A. This is B. Okay, this is C. Now here, this one is B. This one is A. And this one is C here. Okay. So here A is bigger than B. And this is here bigger than A. And still A is bigger than B. But here, this time, A is on the x-axis. And here A is on the y-axis. So we say that it is set up this way. Okay, so you can use this information here to set up the equation or the other things. Okay, let's look at this example. Determine the foci, the vertices, and the lengths of the major and the minor axis of the ellipse with the equation x squared plus 9y squared equal to 9. The first, and graph the ellipse. The first step is always, if an equation is given, the first step is always try to write the equation in a standard form. Here, the standard form is like you have to write this one equal to 1. So it will be x squared, something squared here, and then y squared, something squared here. So these are now the question marks for us. Now we want to find them. Now, how can we make this one 1? So we divide both sides with 9. So all terms, divide all terms with 9. And we will get, okay, the 9, it will be 1 here. So it will be 9 here. So you can say this is x squared over 3 squared, you can say. Y squared 1 divided by 1. This is 1 squared, you can say. It's equal to this. So this is now in standard form. Okay. Now from the standard form, the second step we can do, you can find the x-intercept here. What is the x-intercepts are? Okay, so when you make this one equal to 0, so when you make this one equal to 0, then you will get x equal to -3 and +3. Now, the y-intercept here, okay, you can make this one now 0, this one 0, and then you can find the y values, which are -1 and 1. So it's coming from here, by the way. Now, then you can find the foci. But before doing that, okay, before doing that, it's better to look at where is the foci. It's on the x-axis, y-axis, and the vertices. Where are they? So only these two information is enough. Especially this one is enough to figure out the rest, because we will have, okay, when you make when you draw the ellipse, the x-intercepts are 3 and -3. And the y-intercept is 1 and -1. So it will be something like this. So as you see, 3 is bigger than 1. So where is the focus? So the foci should be like 1, F1, the first focus, and the second focus has to be somewhere here, okay? And the major axis is this one here. Now this is the major axis. And we know this is the minor axis. From here it's easy, and the vertex, where is vertex here? The vertices, the vertex 1 and the vertex 2 is here. Remember that the vertices are always on the major axis. So what is V1? It's 3, 0, and the V2 is here 3, 0. And the length of the major axis is what? Major axis, it's 6, because it's from -3 to 3. And then the length of the minor axis, so its length of the minor axis is from 1 to -1, so this has to be 2. And when it comes to the focus here, you can find the foci. Finding foci, okay, I'll write here. So then first you set the equation like c squared equal to 3 squared minus 1 squared. So which one is bigger? So this one or this one? So you say the big one here minus the small one. So it will be then c will be equal to plus 2 squared 2 and minus 2 squared 2. And then where is the foci? The focus, first focus and the second focus. We know it has to be here like 3, minus 3, 1, minus 1. So the foci has to be on the x-axis. So foci will be, okay, it's better to write here maybe. So the foci will be here. Foci are, it will be like F1 and F2 here. So we know C is 2 squared 2 and minus 2 squared 2. So the foci has to be on the x-axis. So it has to be 2 squared 2, 0 and minus 2 squared 2, 0. Okay, let's do this try and check exercise. Determine the foci, the vertices, and the lengths of the major and the minor axis, and graph the ellipse with the following equation. It says 9x squared plus 4y squared equal to, okay, I'm changing it to 36. It has to be 36. Okay, now in here the first step is write it in standard form. So it means you have to divide both sides with 36 and try to make this one equal to 1. So you divide both sides with 36, and this will give you x squared over 4 plus y squared over 9 is equal to 1. And okay, after this, it's better you write them as a square of numbers here, 2 squared, and this is okay plus y squared over 3 squared equal to 1. If someone asks about this, for example, how to write this one, so you can write this one as x squared over square root 5 squared. You can also write this one this way. Now, after this, you can, in step 2, here you can find the x-intercept and y-intercept. So the x-intercepts are, okay, so what is the x-intercepts are? Here, the x-intercepts are, you make this equal to 0. I mean, no need to make this one 0. It's automatically, let's say it's minus 2 and 2. And then the y-intercepts are 3 and minus 3. Now, after you find them, you can directly tell the vertices here. It's better you make the graph of it because you have to find the long part. Okay, the y-intercepts are minus 3 and 3, so it has to be here and here. And then x-intercepts are a little shorter, so it has to be negative 2 and 2. So in this case, it is kind of, you know, a vertical ellipse. So the major axis will be here. The major axis now this one here. The major axis is this, and here this is the minor one. So it's the minor here. Now the step 3. Okay, we can talk about the vertices here. So always the vertices are, okay, the vertices are always on the major axis. So it has to be 3, 0, 3, and 0, minus 3. The lengths of the major and the lengths of the major axis is, okay, what is the major axis? The major axis here is the longest one. So the longest one will have from 3 to minus 3. So it has to be 6. So the length of the minor axis, okay, this minor axis, it's written here, the minor axis, it will be from 2 to, so this is the minor axis, okay, it's from minus 2 to 2, it will be 4. Now it comes to the focus here. So how can you find the focus? These are our, okay, the vertices. These are okay, the y-intercept and x-intercept. Okay, now the focus has to be always on the major axis, so it has to be the focus always on the long side. So let's say this is F2, this is F1. Let's say this is C and this is minus C. So how can you find C? What's the relation between C and the x and y intercepts? Okay, we have this one all the time. C squared is equal to the absolute value of these, the difference between these two. So it will be 2 squared minus 3 squared, so it will be equal to 7. No, is it? No, it's 5, I guess, yeah. So now we have these two things, like c is plus or minus square root 5. So it has to be square root 5 here, and it has to be minus square root 5 here. And where are the focus now? So you can say here, the focus has to be now, the foci has to be, so foci are now on the y-axis, so it has to be square root 5, so 0 square root 5, and 0 minus square root 5. So, but here c squared, as we stated earlier, it's just you can directly say c squared here is the big one 9, small one 4, so it will be 9 minus 4. You can directly say that. Okay, let's see how it is solved in here. It's better you first draw it and see the minor axis and the major axis. Then it's easy to put the foci and to put the vertex. And because most of the time, most of the mistakes the students do is about the major and the minor axis, because they find a c value for the foci, but they don't know if it is like 0c or c0. Okay, this makes the problem. Okay, let's say here divide by 36 both sides. So I said this has to be 36. So then make them square and then find the vertices. And then the minor axis, major axis. So they're just double of 3 and double of b all the time. So you can say c squared is equal to a squared minus b squared. So this is, you can take their absolute value, no problem. And then it will be, okay, the foci has to be on the y-axis, because the major axis is on the y-axis. Now these things are very clear when you make the graph. Okay, do the graph, you will see it's clear. Okay, clear from the graph. So it's better, instead of memorizing this. I mean, it's okay, this part you can memorize, but for these, the finding foci, it will be better to do from the graph. Now let's solve this example. Now find the equation of the ellipse with center at the origin and major axis of length 6 units located on the y-axis and the minor axis of length 4 units. So the key, the important thing here is that the major axis, the long one here, this is the long axis here, is 6 units and located on the y-axis. And the minor axis, so minor axis is 4 units. So the long one is on the y-axis. So it says the major axis is on the y-axis. It means when the center is the origin, of course. So the center is the origin. The long side, the long axis, the major axis will be on the y-axis. So it has to be something like this then. Okay. Now here it says the major axis of length 6. So 6 means this distance between these two vertices are 6 here, so 6 units. And the minor axis of length 4 units, so it means like the length from here to here is like 4 units, and here to here is 6. Okay, now in this case we have to find, okay, now this, we'll say this is now 4, okay, and this we know is 6. Now we have to find the x-intercepts and y-intercepts. Now since this is 6, so it will be 3 here plus 3, and here this will be minus 3, and here this is 4, and they're same distance, so it has to be 4 is 2 and minus 2. You can divide by 2, you will get 2. You can divide 6 by 2, you will get 3. Now, what's the formula? What's the equation? So the equation is always this, like x over x-intercept. Like you take one of the x-intercepts plus y of x squared over x-intercept squared, y squared over y-intercept squared equal to 1. So take the x-intercept here, one of the x-intercepts, it is 2 or minus 2, whatever you can put here. So it will be 2 squared or minus 2 squared. You can write here 2 squared or minus 2 squared, whatever, because we have squared here, so this will not make a problem. And the y-intercept is definitely like -3 or +3. Okay, you can take one of them, no problem. You can take minus. So then it will be, when you put them here, it will be x squared over 4 plus y squared over 9. Even you take plus here, it won't make a difference. So you will get the same equation, which is x squared over 4 plus y squared equal over 9 equal to 1. This is how we do it. And now here is the explanation of it. I don't want it to overlap my writing and the slide, the solution. Okay, here's what we have. Okay, this is exactly what I explained to you. Now let's do this try and check exercise. It says find the equation in standard form of the ellipse which with center at the origin and one focus at 3, 0 and the vertex at 4, 0. The best way to understand this question is just now let's do this try and check exercise. It says find the equation in standard form of the ellipse which with center at the origin and one focus at 3, 0 and the vertex at 4, 0. The best way to understand this question is just to locate the points in the Cartesian coordinate system, plot the points, and plot the ellipse. You will get some idea. Okay, so the center is at the origin for sure. And the one focus at 3, 0, 3, 0 is here. This is one of the focuses, let's say F1. And the vertex is 4, 0. So if vertex is 4, 0, it will be here 4, 0, the one vertex. So let's say the vertex 1. Now, since the center is here and since the vertex and the focus are always on the major axis, so we will have an ellipse something like this. So you can also say if the focus is here, the one of the focus, and then its symmetry will be here with respect to the y-axis, and then if the vertex is here and the other vertex has to be here. Now, for this one, what's the equation? Let's remember the equation. For the equation, we need this point here. I mean this one, the distance to the origin of this vertex. This is 4, and we need this let's say the x-intercept here 4, and the y-intercept we don't know. Let's say this is a. Okay, let this be a. So the equation will be x squared over 4 squared by x over the x-intercept is 4 squared, y squared over the y-intercept squared, which is a squared, will be 1. Now the question here is how to get a. Now in here we have to look at the relation between, A, B, C. A, B, C mean, what we mean by A, B, C is this. If you have an ellipse like this, you will have a focus here at C, and you will have this one here A, and here you have B. Now in this case, the C squared is always equal to the absolute value of B squared minus A squared, or I can say, okay, B squared, no A squared, minus b squared, because here a is bigger than b. So because we have such ellipse, so kind of horizontal ellipse, so a is bigger than b here. So in this case, c squared will be equal to a squared minus b squared. So we can use this one. So in our problem, the c is here 3, and in our problem, we have 4 and we have a squared, and 4 is bigger than a. So c squared has to be equal to, look at this, which one is bigger, which one is it? 4 is bigger, so we say 4 squared minus a squared. So what is 3? C is, from here, C is 3, so 3 squared equal to 4 squared minus a squared, and we end up with a squared equal to 7. So no need to find a, because a squared is enough, so we can say a squared is equal to 7. So the equation will be x squared over 16 plus y squared over 7 equal to 1. So this will be the equation of line, of the ellipse. Now I want to show you also the solution in the slides. There are lots of ways to think, to approach the solution here. I'm using one way. Depending on your knowledge and experience, you can have some shortcuts. Okay, the focus at 3, and the a is, the vertex is 4, and c squared is, okay, it automatically goes like this, but I would recommend, when doing this part, you have to determine which one is bigger. Is A or B? Yeah, is it this one or this one bigger? This is the important part here. So it's better you focus on, after finding C and A, so you have to say this B, your B here is definitely less than 4, because this is making the major axis here. The major axis is this one. So this is major axis, always have focus, foci, and the vertices on it. So then you can repeat this, c squared equal to a squared minus b squared, and you will end up with 7, and it will give you x squared plus y squared, x squared over 16 plus y squared over 7 is equal to 1.